Okay, where were we before? Okay, I was making the, oh, that's CUDA. It's all a bunch of CUDA functions. What else is there? Oh, I was trying to get CUDA library to work. Yeah, that's right. Okay, now that we have CUDA null unit, CUDA null unit here, CUDA null array. This is just the array. Okay, next thing. We have to get it to compile. Let me check if I have this right. Okay, we're gonna have to turn this into a DLL, a dynamic link library. The reason for this is I've been trying to get CUDA libraries to use Windows, but it's never really worked right. I don't know why exactly. Okay, in order to create a DLL, we have to specify the program as a dynamic link library. I hope I didn't miss anything. Maybe I did. I'm just trying to make sure I didn't miss anything here, because it would be easy to mess things up. Oh, okay. As a rule, I am keeping everything in the same file, but we'll deal with that later. Okay, build project properties, and then general properties, and we set from application to dynamic link library. The reason for this is I can't get Windows programs to work in CUDA. For whatever reason, it just fails completely. Apply. And I wouldn't want to, because I'm going to make multiple CUDA projects, and I don't want to retype all this. And CUDA projects will only compile in CUDA C, which is a special compiler which doesn't work with standard Windows compilers. Okay, apply. Okay, next thing. You have to select release, otherwise it will not work at all. Okay, you have to you remember that you have to select in the CUDA C device, you have to select your own particular GPU for code generation. Mine is 5.0, so you have to select the 5.0. Okay, what else? Build. Let's rebuild. See if it works. And something. Yeah, it seems to work. Yeah, it works. CUDA C.DLL. Okay, that's the first part. Okay, let me just clean things up a bit. If in def CUDA null array. If in def CUDA null array. Okay. If in def CUDA null array. No, the array. Okay, this is gonna cause a minor problem later, because CUDA arrays do not work the same as type null arrays. Define CUDA null array. Okay, if and def. What? Why? The end if end if is missing. That's because you didn't specify it. End if. No. End if. Not end if, NF. Okay, get rid of this. Yeah, good. End if. What? Oh, come on. Oh no, it's just being weird again. Okay, everything's fine. Build, rebuild. Okay, so far so good. Now, here comes the hard part. Okay, we have a CUDA null array. Now, Visual Studio. Let's open up the other project. Come on. Just taking a while. Okay, this is our first project. Everything here is fine. Let's open up a new thread. So just ignore everything after this file. Okay. Include. CUDA library. Oh, I have to select CUDA library. This is gonna take a while because a little problem with using DLLs is that okay, why am I moving this? A little problem with using DLLs is that the DLL file has to be inside the same directory as the program that's using it, unless you do some other stuff. Because but I'm not going to get into that. Library.h. But we have to specify the exact location. Let me find it. Okay, there are so many steps to using a DLL. Step 1, find the library file that's using the DLL. Okay, I'm trying to get to it here, and you have to specify the. Okay, there's one more thing I don't understand. Why is it that the file name uses /, but in C it uses a backward slash? No, they're just reversed. Anyway, okay, so that's step 1. You have to library file. Step 2, specify the location of the DLL. Okay, we have to. Oh, wait. No. Specify the location of the DLL in the. It has to learn how to use the DLL specifically. Okay. Let me just see. I have notes for this. Okay, it is on my notes for how to do a DLL optimization. Step 1. Okay, add DLL support. Under properties C++ general. Under properties C++ general, additional include directories and DLL directories. Under properties, select additional include directories. Okay, let me put this on the side. Okay, under properties, go to properties. Okay, C++ general, additional include directories, add DLL directory. Wow. Okay, eProject, is it / or backward slash? Let's just hope it works. Add a DLL directory. On the properties linker input, select additional dependencies. Okay, let me show you here. Maybe not able to see it. Okay, these are the notes for how to do optimization. Include optimization. On the properties linker input, select additional dependencies and the name of the executable. Okay, under project properties linker input select additional library directories. Additional input. Wow. Okay, this is additional dependencies. Add. Oh wait, am I getting something wrong here? Not input. It's general. Linker general. On the properties linker, select additional dependency and the name of the library. Additional dependency. Oh, it's down here. Whoa, additional dependencies, and add the name of the library. Add the name of the library. Okay, additional dependencies. Wait a minute. What am I doing? How do I add? Okay, edit. Okay, add the name of the library. CUDA library. CUDA library.lib. Okay, this is going to take a while. Okay, next step. I'm going to upload this file into GitHub, just so you know how to do this correctly, because this is going to take a long time. I really don't have no idea why they make it so difficult. Okay, apply. Okay, next, part 3. On the properties linker general, select additional library directories and add directory path to the library. Whoa. On the properties linker general, select additional library directories. Wow, can I even find it? Edit. Okay, there it is. Okay. Okay, I'm not even sure if I'm getting this right. Is it forward slash or backward slash? I have no idea. Okay. It's in there somewhere. Add a post build event. This is the last part. You add a post build event because the DLL has to be in the same directory as the executable file. But I'm gonna have to modify the DLL while at the same time modifying the file that I'm using it. So each time I'm gonna have to copy the DLL back in. Each time I modify the DLL, I have to copy it back into the main file that I'm using it. That's using it. And I don't want to do this one step at a time because it's just too tedious. So I'm gonna add an automatic use xcopy. It's a command line that copies the file automatically. Okay, apply. Okay, on the add a post build on the properties build event. Properties. No, on the properties build events. What's build? Build events. Okay, properties build event. Build event. Pre-build event. Post build event. Okay, post build event. Command line. Okay, right here. We copy this line right here. X copy minus the bracket here. X copy out there. Okay, we copy this entire line right here and then copy it inside this command line here. Out there. Okay, X copy. Okay. Make sure to select all configuration and for both debug and release. Okay, last part. The configuration have to be released. Select all configurations. Make sure to select all configuration. Oh, okay. I'm going to do all of this again because I made a huge mistake. Oh, actually, it's released. Post build event. All configurations. Now I'm going to have to do all this again. Here, you have to select all configurations, otherwise it will not work right. So I'm going to have to do all this again. Let me just pause and do it again because it has to be done for both debug and release. This is what it says here. Select for both debug and release, otherwise you're going to have trouble again. Let me just pause it. One thing I forgot to specify. That path you're supposed to add right here. It's you have to modify it to match your actual DLL location. CUDA library .dll. I completely forgot about that. Okay, path. You have to select the exact path. Oh wait. Let me just copy this right here. Oh, this is complicated. I just hope I got this right. Okay, not CUDA library 2. Okay. Wait a minute. What the hell? Oh. Oh, CUDA library 2. CUDA library .dll. You have to select the full path. It's a command line. Okay. You select the file, the full path of the file, and then out directory, and then copy it to out directory. Okay. Okay. In there, out there. Oh, wait. No. Oh. Oh, wait. It's the full path. Oh, wait. Am I getting this right? Okay, this is getting complicated here. I have to make sure I'm getting this right. Int mat library. Oh. Oh. I'm not even sure which path I'm supposed to be using. Let me pause and check. Oh, that was stupid. It turns out that it's just the same file name. Oh, okay. There's something else I was supposed to check, but I didn't do it. Okay, you have to select the right file name here. CUDA library 2. And when you compile, it gives you the file name. CUDA library.dll. Oh, it's the full file name. And okay, so ed. Oh, there's no end there. Oh, what am I doing here? Okay, so that's it. X copy out there, out directory, and okay, that's pretty much it. Let me just make sure I didn't make a mistake. Okay, it turns out I made several mistakes. Okay, I've been looking up an X copy. The Y, D, and then the path. Oh, you have to read up on X copy to figure out what this means because it's really a lot more complicated than it looks. The Y, that's a parameter. E projects Visual Studio could elaborate to x64 release could elaborate to the DLL. Okay, could elaborate to the DLL out directory. Okay, and $ add directory, and wow, why do we need that? Oh wait, $ add directory has its own, has to be in quotes. Okay, this right here is the full path. Xcopy YD $ Visual Studio CUDA library x64 release. You have to essentially give it the full path of your DLL, and then in quotations $ out there. So if you need more, you have to read Xcopy. It's just a Windows. It's a DOS command line. Oh, that's just too complicated. Okay, let me just review everything because there's so much that could go wrong here. If you don't get it exactly right, it simply will not work. Okay, let's read up on this again. To add DLL support, under Properties, C++, General, Additional Include Directories, hit Apply. Under Properties, C++, I should be coding stuff here. I shouldn't be doing this. Oh wait, it's backward slash. Okay, under Properties, C++, Visual Studio CUDA library. Number 2, under Properties, Linker, Inputs, select Additional Dependencies. Properties, Linker, Inputs, Additional Dependencies, CUDA library.h, CUDA library.lib, Additional Include Directories. Add the CUDA library 2. Oh wait, it's the wrong name. CUDA library 2.lib is the second CUDA library. Okay, under number 3, under Properties Linker General, select under Properties Linker General, select the file name. Additional library directories. Additional library directories. I have to post this because this is way too complicated. Additional CUDA library directories. On the add post build event, on the properties, that's the one I just did. CUDA library 2. Post build event, CUDA library 2 out there. Okay. You use on build, yes. Apply. Now let's see if it works. Okay, add CUDA library. Everything's good. Okay. Now CUDA neural network. CUDA neural array. No, array. Source. No, source 2. Oh, wait. Just ignore all this. Source 2. Result 2. Just have to hope this works. Okay, let's type images, create, copy image list. Okay, source, Create, not create serial. CUDA neural array create, type image create, sequence create, whatever. I don't need to build a network. I have to do a lot of things wrong here because this is getting way too complicated. Everything I just did has to be thrown out. Okay, on network. Type image list, get image. Get image 0. Okay, break. No. Oh no, not break. There's no break. Type images, get image 0. Image 0. Okay. Okay, we have to copy the image into the thing. Whoa. This is gonna be complicated. Okay, type image list, get image, set image RGB. I wonder, no, it won't work. It will not work. Or will it? No, it definitely should not work. Okay, type image create, that node array create with high depth. Oh no, it will work. What am I talking about? Set image RGB. Source 1. We create an array source, create a second array source. Okay, CUDA neural array create. We have a type neural array create. Now we have CUDA neural array create. Source CUDA neural array source 2. Source 2 image 0 dot image length. Image length. Image 0 dot image length. Okay, we're gonna try to do something really weird here. CUDA neural array create image 0 dot image length. Okay, now we have in source result 2. I just hope this works. Result 2 image list, set image RGB, source, and now for the big one. Microsoft, yeah. CUDA neural array set data. Oh, where am I? I'm in the right place. Yeah, CUDA neural array set data. I have so many windows open at the same time here. CUDA neural array create set data source. Okay, copy it here. Set data. Okay, source dot no, source 2. Set data, no, not source 2, and source 2, and source 2, and source dot, no, not and source dot, not source dot. It's not a pointer. Source dot array data. Source dot, not dot, array length. Now we're just checking to make sure that the DLL actually works correctly. Okay, source dot array length. If it does, we are gonna have to copy everything from the type neural network into CUDA neural array. Oh, CUDA is really complicated. Okay, CUDA neural array set data. CUDA neural array copy. Oh, we need copy. Okay, now we need copy. Okay, CUDA neural array create, CUDA neural array set data, CUDA neural array copy. CUDA neural array copy. Parent and source. This is the copy from one neural array to the next. Source. If parent.array length not equals source.array length. No. source the CUDA memory, copy device memory. Device memory parent.array data, that's the destination, source, parent.array length. Array length. Parent source.array data. Source.array data, parent.array length, size of the array length plus CUDA neural unit. Okay, that should do it. And then copy it in. DLL export. Okay, what is it complaining about? Define DLL export. So what's the problem? Buzzing operation might consider adding a hint file. So potential fixes. No, I'm not doing that. DLL export CUDA library kernel. If in def CUDA library kernel. Yeah, it's there. Okay, save and we build. Okay, now for the other one. CUDA always set data. Okay, set that, not set data. Get data. Copy data. Copy data from result into result and result from source. It's a very simple operation, but there's so much that could go wrong here. Why copy data? CUDA library.h. No, don't copy that. Just copy. I just call copy. Oh, whoa, whoa, whoa. Oh, what is that? Something's not right. Could not already destroy. It's complaining about something. Ah, it's nothing. No. Couldn't already destroy. Yeah, it's complaining about something, but it doesn't actually mean anything. Okay, source. Copy data. And now we reverse it. Couldn't already set data. No, get data, not get data. Set data. Get data. Source 2 into result. No, result 2, not result. Oh, that could go wrong. That could go seriously wrong. Result 2. What? Not copy data again. It just copy. Couldn't already copy source from source into result, and then from result into result data. And now for the moment of truth. Okay. Will this work? No, we still need to do one more thing. To overload, CUDA neural array copy. There's no overload. CUDA library. One overload, CUDA neural array copy. What's the overload? Oh, yeah. It's messing me up here. CUDA neural array copy. It's telling me that something's wrong, but I can't see what's wrong. Okay, it doesn't matter. Just ignore it. CUDA neural parent source. Yeah, it's just messing me up. I don't know. Okay, there's no I. Just at 0. Why is it saying that it's wrong? Anyway, and bitmap show. This is important. Okay, CUDA neural array copy. Let's see if I got this right. Load the image, load the directory. We get one image, and then we create an image source result, and then oh, what the hell? No, we're getting this twice. We like that. Set image RGB source. We copy the image into this neural array, where it takes a special function. Then we create a CUDA array, and we set the data from the CUDA array into the CUDA array, and then copy it into another CUDA array. Then we get it back, and then copy back into an image to display. And all of this hopefully works at all. Oy, oy, oy. It probably will not. Let me check what's wrong. Okay, after a lot of trying, I finally figured out what I did wrong. Right here, it's supposed to be a pointer to a pointer, but I just passed the pointer at 0, which is completely wrong. It's supposed to be and data. You're supposed to set a pointer to the pointer, and instead I just set a raw pointer, and of course allocate memory failed completely. Okay, let's just see if it works. Okay, step 1, let's build it, and oh, it won't build. Stop. Okay, step 1, let's build it, see what happens. We build, and it's building, and it creates the DLL file. Did we remember to copy the DLL file? Okay, let's see if we can find it. Yep, that's the new file. So I have two windows open over here. Okay, so this is what we did. We copied the image into source array, and we copied the source array into the CUDA array, and then we also now we create two arrays, and then copy the data of the source array into the CUDA array, then copy the CUDA array into another CUDA array, and then we get the data back, and then we get the image back. Now we find out if it works. Okay, we build and we run it, and yep, it works. We can't be sure that's what happened, but from the code that I see right here, so this is what's supposed to happen. So the CUDA part works. Now I'm gonna see if I can make it work, do something else, something more, well, more obvious. Okay, let's get back into the file right here. All right, we got copy data, set data. Now we have to create a new copy, not copy, add. What can I do? Reverse. New array, reverse, or it doesn't matter. Just do something, anything that will let me know if I got everything right. Okay, reverse. Parent source. Okay, if parent not equal length, no. Okay. So now here comes something really difficult. I have to copy and paste it because it took me a long time to figure this one out. Okay, threads per block, blocks per thread. This is a DIM tree. This one's rather complicated. So here I set it to 512 because that's how many compute units that my GPU has. But if you are doing 3 dimensions, like I'm going to be here, we're only doing 1 dimension. This is a 3-dimensional thing, but the other dimension is set to 1 by default. Okay, 8 times 8, no, 8 by 8 by 8. The only important thing that it has to add up to the total number of GPU threads you have. If you're doing 3 dimensions, you have to divide this into the individual dimensions. I'm not sure if you have to do it, but it works better if you do. Okay, right now I'm going to set it to 1 dimension, 512. Okay, parent.array length. Okay, now plus thread per block plus 1 divided by threads per block, because we have to take the total length and divide it into a number of blocks that are each 512 in size. That's just something you have to do. Not sure why it works that way, but that's just the way it works. Okay, Now we have to call a kernel. Okay, it's global. Okay, I'm waiting for the from the documentation. It's double underscore global. Okay, that's what it says to do. Global underscore global. Kernel. You can call it whatever you want. Kernel reverse. Okay. Okay. CUDA neural unit. Unit result. CUDA neural unit source. No, source. No, pointer. CUDA neural unit pointer source. CUDA neural unit pointer source. And length. Okay, one more thing to remember is that this operation right here, when you add the length times squared per blocks plus 1, gives you a result that's slightly larger than what you specify. So, no, kernel void, kernel void. This one now you have to check if it's correct. Now I'm going to copy from the documentation here. Unsigned long. Okay, unsigned long. Whoa. No, thread ID X, thread ID X, Y. No, that's thread ID X. Now you have to select which one. Okay, block dimension, thread dimension. It says so in the CUDA one-time documentation, but I never quite understood what that means. But anyway, right now you have X, and then you could have Y, and then you have Z. It's three-dimensional. Okay, here we're only using one dimension, but you could do two-dimensional. But here's the one important thing. If I is more than or equal length, return. This is very important because the indices are larger than the length, so you have more threads than you actually need. So the extra threads would have to return. That has to do with the fact that the threads are divided into blocks, and the blocks are divided into threads, and a lot of complicated stuff that I don't really get at all. Okay, result dot I equals source dot length minus I minus 1. We're just going to reverse everything, and doesn't really do anything. Okay, next. Okay, kernel reverse. Kernel reverse, and then triple, and then we have to do triple this thing right here, triple caret, triple open, triple close, and then we have to add in the right order. I'm reading off the documentation here, trying to get this right. We have block per grid first, and then threads per block. We have to get in the right order, otherwise it will not work at all. Oh, it took me a long time to figure this one out. Okay, threads per, and then the parameters. Okay, parent dot array data source dot array data parent, no, let's just say source dot array length, source dot array length. Okay, and now another important thing, you have to synchronize the device. If you don't do that, then things are gonna break. CUDA memory synchronize device. Let's just copy and paste. Find it. CUDA memory device synchronize. It's very important to do this, otherwise things are really gonna break. Okay. It says there's an error here, but there isn't. That's just C and C plus and CUDA C are not really the same thing. So there's a clash between the two. So it always going to report an error here. It always going to cause some kind of error, but it's not actually an error. It's expecting a double caret, but it's getting a triple one, so it's going to revolt. CUDA array reverse, and then we copy it in the CUDA library. Okay, DLL export, and then put this down here, and then compile, rebuild, see if it works. I didn't forget anything, and it worked. Well, actually it compiled, but I'm not sure if it worked. Okay, we copy. Instead of copy, we reverse. No, just replace copy with reverse. Yeah. Okay, kernel array reverse. Okay, build, rebuild. It should work, but unless there's something wrong. 1 succeeded, 0 failed. Why is it? Of course it's defined. Okay, let's run it. Okay, it reversed everything. Good, it worked. So now we have a CUDA function, a CUDA library, a working CUDA library. So from now on, the next challenge is just copy all the type neural array stuff into CUDA library, into the CUDA version. Okay, now we're gonna take all of our CUDA code and then copy it into CUDA version, and then we make the neural network to work with CUDA, and hopefully things will not crash. Okay, CUDA neural reverse. It's still not. There's nothing wrong here. Okay, do I still have it? Yep. It just reversed the colors, reversed everything. So it worked. So we're done. Next time we're gonna do more CUDA stuff.